Right triangle application problems. The angle an upward line of sight makes with a horizontal is called the angle of elevation. From the horizontal up to the line of sight is now our theta. You can also go the other direction. The angle that a downward line of sight makes with a horizontal is called the angle of depression. So here is a horizontal, and we would be going downward. But the good news about an angle of depression is that if you draw in another horizontal, by using, and we're saying that these are parallel to each other, by alternate interior angles, you can also move your theta down into the bottom right-hand corner of a right triangle. I'll even just draw that solid. So then both of the angles end up in your either bottom left or bottom right-hand corner, depending on how you draw your picture. So the good news is that they end up in the same spot. Examples. What is the height of a tree if at 200 feet from the base, the angle of elevation to the top of the tree is 20 degrees? So let's draw our pictures. So here's my tree. I'd like to know the height of this tree. 200 feet from the base, that's where I am, or we're measuring, and the angle of elevation to the top of the tree, so if I connect that up to the top of the tree, is 20 degrees. So now I've got a side length and an angle, and we can use trig. So this is my opposite and my adjacent. So this is a tangent, this is an opposite and an adjacent, so a TOA. So it's the tangent of 20 equals h over 200 times 200 on both sides. H equals 200 times the tangent of 20. That's an exact answer, but this isn't a context, so this is not very helpful to know how tall this tree is. So we're going to use our calculator to get an approximate answer, which is 72.8 feet tall. Let's try another. If you're standing on top of a building looking down at your friend, so here's my building, I'm looking down at my friend. You know the building is 35 feet tall, and your friend is standing 20 feet away. What is the angle of depression? So recall, if you're looking downward from a horizontal, really this is your angle theta, but due to alternate interior angles, we can put it on the inside of our triangle down here in the bottom corner. So now I can work with this as another opposite and another adjacent. So this is another tangent of theta is 35 over 20. We inverse tangent both sides. So the inverse tangent of 35 over 20 is our theta. That's an exact answer right there. You can leave it as an exact value, but this is in context. So let's get it to the nearest whole degree. That's going to be theta equal to approximately 60.3 degrees or 60 degrees. I did one decimal place. It didn't really say. So we used inverse tangent to get our angle measure. Let's try another one. You're skiing down a mountain with an altitude. This is a vertical altitude of 1,200 feet. So here's our mountain. The vertical feet is 1,200. The angle of depression is 21 degrees, so recall that that would really be this, but due to alternate interior angles, I can put it down here as well. Find the distance x that you ski down the mountain. So we want to know how long is this run. So we've got an opposite and a hypotenuse, so that's a sine. So the sine of 21 is 1,200 divided by x times x. Then divide off the sine of 21. So x, or the length of the trail, let's go to the approximate answer. The exact answer would be 1,200 divided by the sine of 21, and it wants it to the nearest foot, it specifically said, so 3,349 feet long. Awesome. Let's do a little review from our last lesson. Find the three trig ratios for angle B. So that's going to be our theta as angle B. And then find the measure of angle A and angle B. So pause this video and try this review on your own. So you use your trig ratios to get your comparison of your two side lengths, and then we can use inverse trigonometry to help us work backwards to get the angle measures of angle A and angle B. We're going to use this knowledge here to do what's called solving right triangles. So how do you solve a right triangle? To solve a right triangle means you find all the unknown sides and all the unknown angles. So you know every part of this right triangle, all three sides and all three angle measures. So here's our first one. We want to know all three sides and all three angles. So I know two sides and I'm missing a third, so I'm just going to take a little inventory. I want to know side length L. And then I need to know angle L, which I know is going to be a degree measure. And I also need to know angle M, which is also a degree measure. So our answer is going to be three parts: side length L, angle L, and angle M. First thing that's easiest to go for is side length L using Pythagorean theorem. So we've got a squared plus 14 squared equals 18 squared. A squared plus 196 equals 324. A squared equals 128, and we're going to reduce that. The largest perfect square that lives inside of 128 is 64 and 2. So A is going to be 8 root 2. I should have called that L. So this side length is 8 root 2. Then we can use inverse trig to help us get angle measures. That's the only tool in the toolbox that can help you work backwards. I'm going to use the side lengths 18 and 14 because I don't want to work with the 8 root 2. So this is from L, that's an adjacent and a hypotenuse, so it's going to be an inverse cosine. So the inverse cosine of 14 over 18, adjacent over hypotenuse. So that means the measure of angle L is approximately 38.94 degrees. Then we can use triangle sum theorem to get our last angle measure. So you can just do 90 minus 38.94, which is going to get you 51.06 degrees. So we used Pythagorean theorem to get the third side, and then we used inverse trig to work backwards and get our two angle measures. Let's try one like this that starts with a side length and an angle measure. So if we have a side and an angle, we need all three sides. So let's give this a name. So let's call this A, B, and C. So we're going to need side length C, and we also need side length A. So two side lengths, And one more angle measure. I need the measure of angle C, which I know is degree measure. So the easiest one to do is the measure of angle C, because I already know two of them. So 90 minus 38 is going to give me 52. So 52, I already put my degree measure. So this is 52 degrees. Then to get side lengths, we're going to use regular trigonometry. You can use the 38 or the 52. I think I'll use the 38 just in case we had made a mistake on the 52. So we're looking for, let's say this is side length C. So I want an opposite and an adjacent. So it's going to be a tangent of 38 is 5 over C. Times C on both sides, and then you divide by the tangent of 38. So C equals 5 divided by the tangent of 38 exactly. We can also use trig again to get side length A. So that's going to be a 38 is 5 is opposite of 38 and A is an adjacent. So it's going to be sine. And this is going to be another division one. Hopefully you're starting to notice that if the variable's in the denominator, your answer is going to end up being a division. So A equals 5 divided by the sine of 38. Exactly. Let's take it to the next level and let's try a bigger problem. Solve this triangle. So let's take an inventory of what we need. So we need angle B is a degree measure. I need side length A, which is just a side length. And we also need this long side here. We need side length B. So we're looking for an angle and two sides. The easiest one to do first is definitely the angle measure using triangle sum. So we got 40 plus 35. And that is 75. 180 minus 75 is 105. So then we're trying to get angle side length A and side length B, which is this guy. So right now we can't use trig on this problem because it's not a right triangle. 40, 35, and 105 is not a right triangle. But if you draw down the altitude, you can split this triangle into two right triangles. You have a right hand right triangle and a left hand right triangle. If you ignore the right side, on this side length you have an angle and a side length. Yay, that's enough to use trig. So then what we're gonna do is we're gonna shoot for this height here in between so that I can use it to help me get that side length A. And then we're also going to need to know this, these two chunks of side to get that whole side length of B. So this is going to be a missing length X, and this is going to be a missing length Y. So first thing we're going to shoot for is that side length H. So from 40 degrees, H is opposite, 20 is adjacent, so it's a sine. So the sine of 20 is sine of 40 is H over 20. So then times, so then we've got H equals 20 times the sine of 40, exactly. And I can even, I'm gonna write it onto my diagram here. So this is 20 times the sine of 40, just for future reference. So that length is 20 times the sine of 40. Now I can use this to help me get this side length A. So now I have an opposite and a hypotenuse missing on this right side length. So it's a sine of 35 equals opposite over hypotenuse. The opposite is now 20 sine of 40 divided by my hypotenuse, which is the length of A. So times A and divided by the sine of 35. So A equals 20 sine of 40 divided by the sine of 35 exactly. That's the exact length of A. Let's go ahead and take it to an approximate, though. The side length of A is approximately 22.4 when you use a calculator. So now we're going to use trig again to help us get these two lengths, the length of x and y, and then we'll add those together to help us get the whole side length of b. So we want to get an adjacent and a hypotenuse. So that's going to be the cosine of 40 equals x over 20. So x equals 20 times the cosine of 40. Whoops, I'm sorry, you can't see that. So x equals 20 times the cosine of 40. And we're going to do the same thing with y. So that's going to be an adjacent, and let's use adjacent and opposite, so to use a tangent. Tangent of 35 equals the opposite over adjacent, 20 sine of 40 divided by y. This will be a division one. So y equals 20 sine of 40 divided by the tangent of 35. And then x plus y equals those two things together. So let's get the decimals for them. So 20 cosine of 40 is 15.32. And y is approximately 18.36. So then if we add those together, we get approximately 33.7. So then our last part says find the area of ABC. So that's going to be base times height divided by 2. The base length is what we just found, 33.7, times the height, which was 20 sine of 40, divided by 2. Punch all that into your calculator, and you're going to get 216.5. Thank you.